Hi, I'm Delaney, and this is my audition for the shy yet brilliant girl who corrects the teacher during class.
I'm really bored, and I wanted to see if I could mathematically make an equation that works out with all the steps that Delaney described in that video, and it turns out you can, and I'm going to get into it. There's one exception, though, that's kind of weird. I'll get at the end, but it's fine. But yeah, let's go through her video and see all the steps she describes, and it'll line up with the stuff over here, okay?
And so you see that would make the remainder 2.1.
The answer is 2.2.
Okay, well, the remainder increases from 2.1 to 2.2, so we're going to cross that out.
It's simple, really. The imaginary number is a multiple of pi.
Okay, this one's actually so cool. So an imaginary number that's a multiple of pi just screams Euler's identity to me. So we're going to cross this one out, and I know what I can do with that one, okay? We're going to do this. Euler's identity says that e to the power of I times pi is -1, which is wild, but we're going to use it.
And where you went wrong is by removing the parentheses.
Okay, we're removing parentheses to cause a mathematical error. This was like the trickiest part for me, figuring out how to make this work, but we'll do it, okay? So we're gonna cross that out.
You have to divide the square root by -2, which increases the decimal by 1, making the remainder 2.2.
Now, this is how we'll make the parentheses going away actually work out. So we need division to happen when the parentheses are not taken away. So it's going to be kind of weird, but let's cross this out, and that's going to make the decimal increase by 0.1 from 2.1 to 2.2. She says makes the decimal increase by 1, but I think she means by 0.1, so don't worry about that. Oh yeah, we can cross that out too. And she said the remainder is what increases. Now, remainder usually is division, but you can't have a decimal as your remainder. That wouldn't make any sense. So I'm thinking she's using the slightly not normal definition of remainder to be the thing you get at the end of subtraction. Yeah, so take that as you will. I messed around with this for so long, and this is the equation that I think we're going to want to work with. So this A and B, you can actually find that using a system of equations in Wolfram Alpha, which maybe I'll do a video about. And then this square root of e to the 2 times I times pi looks scary, but it's actually just equal to 1. So this whole thing is just equal to 1 times A plus B. Multiply this whole thing by -1/2, and then it will fit all of the constraints that she says in the video. It's really wild. I want to show you guys. By the way, these were the coefficients that I got for A and B. So A is going to be -1/15, and then B is -13/3. They're really weird, and they work out. It's wild. Just trust me. If we plugged in A and B, we would get something that looks like this, which is kind of messy. But this would be what they're solving for the answer for, and this is where the mistakes come in, right? So the teacher removes the parentheses. And what that means now is instead of distributing this -1/2 to both of these, it is only next to the B. And that means that we're not just dividing the square root by a -2. Okay, so we hit like 2 of the rules. Now some bored person in the comments can work all this out, and the answer is going to be 2.1, okay? That's the teacher's answer, which is wrong. Now here is Gabriella from High School Musical's answer. She is going to distribute this -1/2 to both of these by leaving the parentheses there and keeping them. That means she's dividing the square root by a -2. This imaginary number is also a multiple of pi because there's a pi right there. So that means we're hitting like every single one of the goals. And by distributing that, we increase the decimal by 0.1 from 2.1 to 2.2. And you can work that out if you want to. It's kind of a pain with all these weird fractions, but yeah, it works out. So yeah, you made a problem that is feasible. That's actually really impressive, even if it was on accident probably. So good job. I'm gonna go to sleep or something.
Well, that's correct.